I'm associate professor at UQ Business School and also work quite heavily with MIT Caesar on practical research, practice-oriented research projects. My my own research is very much focused on data and analytics AI for that matter, but for the last 15 years, I've been looking into data, how organizations use it positively, negatively, and also what impact it creates on society and how do we prevent the negative impacts of data and sort of AI technologies. Um, just wanting to dive into this, just bringing you what is the origin of this configurational theorizing. And I would say that I have this balance of content here that is sort of method oriented, but also at the end of the day, it's a configurational theorizing or QCA, qualitative comparative analysis, is an approach for theorizing. And I think this is the part that a lot of my interest is. And I think a lot of the scholars, they have this new approach for theorizing, which helps them to look at the phenomenon differently, to develop new knowledge differently. So that's sort of the opportunity that this approach or configurational theorizing brings for us. It is actually originated in comparative sociology. I'll give examples of what that is and what does that mean and why these guys actually were the first to think about this method. So in comparative sociology, so let's say we are trying to create insights about different countries. We are comparing 25 different countries and we're trying to understand how they are different in certain variables at the time. Variables, the QCA is not about variables per se. I will talk about that. But that's the quantitative camp, right? The quantitative camp was very much interested in the impact and net effects of variables and how it influences a certain outcome. They were interested in the statistical generalizations and a really large number of cases for that matter. But then you had this qualitative camp, right? Really interested in deep case knowledge and narrative explanation of those case studies. Very different from the qualitative camp. And I would tell you that I don't have firsthand evidence of this, but I'm pretty sure that in the review process, if you are a qual person and you get a quant, reviewer, there will be quite a bit of back and forth in terms of hopefully people are now open-minded, but I think in the past there has been really this separate and divisions in terms of the research communities. So really tensions between, shall we have many cases, many instances of our what of the phenomenon we're studying, or should we focus on n and smaller n and do more detailed, more qualitative, rich insights when we're collecting data, analyzing data? Shall we focus on variations? X goes higher, then Y goes higher, or shall we really try to understand change through understanding the process and elements of a process, right? Shall we focus on this dependent variable? Okay, what are the variations I can explain in quality of an information system artifact? Or shall I focus on that deeper dive change? So these you will know and be aware of this hopefully by now in your PhD studies. And I know that this probably excludes sort of design science oriented sort of approaches and so on. But even in design science, you try to rely on qualitative approaches or even survey approaches to collect your data. So in a way, it could involve or include those kind of studies as well. So Charles Reagan was the sort of professor who introduced sort of configurational theorizing as a third path. So rather than doing really large N study where we survey, let's say, 800 people and we have little understanding of their context. Yes, we can measure some contextual variables and so on, but we really don't know their contextual information and we can't explain in this detail what has happened. Typically, when we develop measurements, they become abstract. We can't really contextualize our measurements for the specifics of each, let's say, organization we're studying. So he really attempted to develop a formal tool way of theorizing for cross-case pattern analysis. So typically in qualitative case, he wasn't interested in just 2 cases, 3 cases. What he was himself studying, he had 25 cases because he was studying countries, and he knew really well those countries. So basically what you see on the right-hand side of the slide is his data set. It's a data set he actually provided when I did his course. What you have at the first column is the cases, and these are the countries. And he was, as a sociologist, was trying to understand which are the companies that have protests in. So the outcome variable is your final column there that has protest in. So country A, they had prior mobilization, they had severe austerity, they had government corruption, they had price rise, and well, in that particular case, because we know this country really well, they didn't have this protest outcome happening. In country B, so it might actually be useful for me to put my laser pointer on to show you where I am. So these are the different countries, these are the outcomes, and these are the variables in the quantitative language, so research language. And these are the values associated with each of these countries. So country B, they didn't have prior mobilization, they didn't have severe austerity, they didn't have government corruption. They did have government corruption, so that's the value of 1. They didn't have price rise, and they didn't get protests. So they had this for, let's say, 25 different countries. So it's not just 2 cases or 3 cases where in qualitative research we will say cross-case analysis. So we would be able to dive into the really rich verbal. We would use words and the qualitative textual account of things to understand the cross-case analysis of our material. In this case, as you see, it's a bit formalized, right? So for prior mobilization, you could have a very deep qualitative account of what was that prior mobilization in that country, why it happened, how it unfolded. But at the end of the day, what Charles Reagan said it didn't happen. So he actually formalized it and gave it a score of 0. Whereas for corruption, they did have a corrupted government. He had many data on that, but he gave it a score of 1. And now you have, let's say, 25 different examples, instances, or cases of when protests happened, right? And you could go and basically, mathematically, it becomes a mathematical problem now. He turned it into Boolean logic and set theory. And he tried to solve this problem of when protests happen. So that was the research question, through sort of understanding what are the combinations of these 4 different variables that ends in the outcome of 1. And how can we reduce it into some sort of parsimonious set of interactions that we can then explain when protests happen, sort of complex in a way interactions. And one of the insights he shared was that when he was doing this analysis, there were 2 countries, I don't know which rows they were, but there were 2 countries that they had the exact same numbers or scores for these conditions, but they had different outcomes. So it was, they call it contradiction in configurational or QCA language. So there were exactly 2 same cases with the same scores for all of the conditions, causal conditions. They had different outcomes. One protest happened, one didn't. He then, because he qualitatively deeply knew and had deep knowledge of these cases, he went and looked, oh, okay, this is country A, this is country B. Here in country B, the protest didn't happen. Based on all of this knowledge I had of these cases, why? And then he realized, oh, this country actually has an oppressive government. So people actually are afraid to come out. So what he did then, he added a 5th causal condition, right? Oppressive government. And now for each of those cases, he had 2 different configurations, 2 different combinations of these causal conditions that one produced when oppressive government was present, protest didn't happen. And when oppressive government was not present, protest did happen. So that's, and I'll explain later, that's part of your counterfactual analysis, and how this deep knowledge of the cases helps you to build formal, not just qualitative verbal, but formal mathematical explanation of what combination of variables do you need to explain this particular outcome. I want to connect back to IS research. In IS research, one of the main articles that have always inspired me about theorizing is Andrew Burton Jones' Aegis article on theoretical perspectives in IS. Most probably you have read it. If you haven't, I really encourage you to read it, because this is where you can see how configurational theorizing can actually help. In a lot of the management research, we have variance theorizing. And then we have process theorizing, the work of, Langley, many of you might know it. And then Andrew introduced that we have systems theorizing, building on the work of many systems theorists and scholarly work that has happened through that approach. When we talk about variance theorizing, we talk about certain variables influencing an outcome, and it's correlation based. So primary emphasis on covariation among properties within a system. So property X goes high. Let's say within the system you have modularity is higher. Let's say quality goes higher, or user satisfaction goes higher, or something like that, right? That's variance theorizing. We use survey to measure the variables, and we analyze the data typically with structural equation modeling and methods like that. Process theorizing is completely different. We're really interested in time and temporal unfolding of events. So we're really emphasizing sequence of events within a system. Something triggers, typically, a set of events, then we are really interested in the ing form of verbs, like, let's say, explaining happens, and then visualization happens, and then until you get to that, let's say, effective decision making, which is the outcome of the system, right? So there's a certain events in a sequence, in a temporal manner, that you do process tracing, and you identify those elements of the process, you can visualize it, and then you turn it into a process model, which explains how a certain change or a certain phenomenon has unfolded. Then Andrew talked about this systems theorizing, and systems theorizing, it's all about, we all have heard, the whole is greater than some of its parts. So that there's interactions between different parts of the systems, and when their interactions happen, we have emergence. And typically, emergence meaning the higher order system at the next level has new emergent properties, and you cannot reduce the emergent properties of that higher order system to individual parts, to each of these squares, because the emergent properties have been developed from the interaction between these parts, not just one single part. So I have very quickly examples of this. Let me actually go to my examples and then come back to this, because I will be sharing my slides. I thought I'll have all of the differences I can find from the various sources I have for you, which I will also provide. But this is an example of a variance model, right? It might look like, you have boxes and so on. It might look like a sort of a process model, but it's actually a variance model. You can look at, the pluses. So when it's a paper by one of my actually friends and previous colleagues, Manho, part of her PhD that was published in MISQ. And she was trying to understand the effective use of BI, business intelligence systems, extending Anders' work on effective use of information systems. So her variables were BI transparent interaction. If you have that higher, then representation fidelity is higher, then you have more informed decisions, right? So she went ahead, did a survey, and all of this work was correlational evidence she collected. And I'm sure she also collected some interview data to validate her outcomes. But basically, all the relationships you see here, at the top, you have systems quality. The more the quality of the system, the more the transparent the system interaction is. If you go back to her paper, you will find, hypotheses. That's what's common in that kind of research. Then we have really examples of process research. So this is Huber's paper in Journal of Management Information Systems. I think one of the really great qualitative process theorizing researchers this group is. I have read multiple papers of them and really, really lovely. When you look at the left-hand side, they have identified these patterns based on studying episodes of what was really happening in the particular cases they had. So a particular event triggers, this is the ing form of verbs that I was telling you, something that is happening, compensating, enabling, right? And from there they model what that leads to, and then other interactions that happen to be able to explain, substitution of formal contracts, combined substitution, and complementarity, basically. So these are, but this is here is not, you don't think. That's why I want you to be really sensitive to this mindset, the language of configurational theorizing. It's not about this event is higher, the substitution is higher. It's not about that. That's variance theorizing. In process, this happens and triggers a set of other things to happen until the outcome is achieved. Then we have systems theorizing. This is one of the papers published by Ning Nang. She does a lot of simulation studies and complex adaptive systems research, where she talks about emergence, right? And this is a very good example of systems theorizing, where she's trying to understand collective level of IT use. And there is a lot of interactions between IT features and human actors. And had this emergence, you can't reduce it just to the feature or just to the actor. It's the interaction that produces these emergent properties of these collective IT use patterns. Again, you can go to these papers to really see where, and of course, one of the points Andrew makes in the paper is that you can combine these and you have more sort of tools in your hand. Just to show you a research model of configurational theorizing. This is a paper, Yonggi Park, Omar El-Sawi, and Pierre Fils, published in Journal of Association for Information Systems. They were trying to understand organizational agility associated with use of business intelligence systems and so on, basically IT. These were kind of the variables. I mean, in QCA, we call them causal conditions or shared antecedents or attributes or whatever we call them, but let's say causal conditions. These are the causal conditions. They know agility is influenced by these conditions, not individually. So they're not connecting IT directly to agility, but they're saying that IT plus other organizational factors plus environmental velocity together combine to produce this organizational agility. This is the theorizing approach. Combination of causal conditions will produce organizational agility. You might think that there's a bit of a similarity between systems approach and configurational approach, and I think that's correct, because I think configurational approach also kind of builds on this sort of systems approach, but it really emphasizes from a theorizing perspective and knowledge contribution perspective, what are these combinations that produces this outcome. I'm just going to quickly go back to these sort of differences here. So I'm not going to go through detail because I did explain quite a bit. So maybe, just from a core logic, in variance, you have covariation, process sequences, process tracing, and here you have, in systems, you have interactions between components, parts, and in configurational theorizing, you have set-theoretic logic, where you're trying to understand what are the sufficient and necessary conditions for something to happen, which is how we develop new knowledge. In terms of causality, I'm going to come back to it. It's conjectural and asymmetric and ecofinal. So I will come back to this and explain what each of these words mean. But in process theorizing, we have temporal. in causality for, in variance models, we have linear causality or non-linear, as we can do complex sort of stats and so on. So I will leave this video. You can look into the details of this, but maybe let's look at the limitations. In a lot of the variance model theorizing, we try to generalize and we abstract out and we ignore complexity. In a lot of the process theorizing, we focus in 1, 2, 3 cases, so we struggle to generalize. In a lot of the systems theory, emergence is really hard to explain. So developing a parsimonious model, a precise understanding of how the interactions unfold and emergence occurs, it's really, really hard. And with configuration, you can handle complexity. You can generalize more than just qualitative research. And you actually can do it with some parsimony. The way I was showing you the Reagan's data set, you can actually develop some generalizable insights from it. So let me go forward. So this is just to get your setting in terms of what kind of knowledge you produce with this method. So what is QCA really? It's a method to bridge qualitative and quantitative analysis. It gives you the ability to model causal complexity. I have a slide to explain what is exactly causal complexity. But if you're writing a paper with this approach, you really need to upfront my experience of writing QCA papers, justify and explain why you have a situation in which you have causal complexity, why your phenomenon is causally complex. I'll explain what that means. And it facilitates a lot of counterfactual analysis, a bit like researchers' mindset, very important, and knowledge, very important, a bit like Reagan going into the analysis and saying, this country actually has oppressive government, so that's changing the dynamic. So you engage in that kind of counterfactual analysis. It's ideal for small to intermediate end research designs. I'm very aware that a lot of the surveys now these days are being analyzed with this method, but that's not the core strength of it. So I personally have preferred to go at QCA, use QCA with my qualitative data. And I'm going to show you examples of all of this. So let's start with causal complexity, because as I said, when you're doing this method, this approach of theorizing, you need to really justify do you have a causally complex situation? And to the extent that it needs to be present in your paper. This is also my opportunity to actually tell you how this method actually came into IS, because it was in sociology. Pierre Fist took it into management and published in Academy of Management. It has been long, actually, has a huge history in management because of Pierre Fist's efforts. But then Omar Al-Sawi and Pierre Fist, they're in the same university, so they were collaborating with each other, including with Young-Ki Park, who later published the MISQ paper of how to write QCA papers, which will be one of the readings that I will provide to you. But this paper is amazing. I think it was published in 2009 or 2011, probably 2009, but it was close to 2010. So it's been, let's say, 15 years since Omar Al-Sawi actually brought this to us. And he was the person who really inspired me to look into this method. As part of my travels, I went and visited him, and I engaged with him in really interesting conversations and learned a lot from him. So if you wanted to look at someone's work in IS, would be Omar Al-Sawi's work and Young-Ki Park's work. And what he did, he was at the time, if you look into his research with Paul Pavlou and other students they were really looking into this dynamic capabilities and how companies actually develop dynamic capabilities. That's one of the things, that he was really interested. And he knew that the environment is very turbulent, things are changing in the environment, and dynamic capabilities are a way to respond to the changes in the environment. And of course, we are IS researchers. So this is where he was trying to bring that this is actually causally complex. It's actually not just one thing. Digital ecodynamics are pretty complex, and because configurational theorizing actually use set theory, so this is like Venn, these are actually sets, Venn diagrams. So he tried to bring these dynamics that when we are studying digital phenomena, we actually have complex causality. Only IT is not going to explain what is happening. Only just your dynamic capabilities without IT is not going to help you explain outcomes either. So it's the combinations. And he built one of the earlier models using the FSQCA approach software. And he basically said IT systems, this, different kind of systems, dynamic capabilities and environment of turbulence. And based on the analysis, he developed configurations for high performing firms, low performing firms, and very high performing firms. And so this was one of the first instances that this approach was. I always use his paper and his insights to argue why the phenomenon I study is causally complex and why I need this approach. Later in the 2020 paper, 2021, Yankee Park and Omar Asavi, PFS, the crew basically published a paper in MISQ on how to do configurational theorizing. So I would say when I was publishing my first paper with this approach, the research methods section of the paper was quite like a tutorial because they were just constantly asking me, what is this? What is this? Explain this. And, there was not much familiarity. But now that MISQ paper is published on the topic, so it's much more common to actually see QCA papers, QCA tracks, and people working basically with this approach. In that paper, they also talk about theoretical multiplicity, so which is another advantage of this using QCA. So this is about using multiple theoretical perspectives. When we look at particular phenomenon, we typically come at it from one certain lens. I'm coming at it from absorptive capacity lens, and that's it, right? And if you want to mix it with other, it's just you get into troubles, right? But because we are looking at different impact of different things together, it actually gives you the opportunity to bring those different dimensions, different theoretical lenses to explain why something is happening. And the phenomenon is complex. So just reducing and using one theoretical lens is just not sufficient. So for that perspective, using Andrew's theoretical perspective paper, it gives you more conceptual latitude, meaning it gives you more range of concepts you can bring to explain your phenomena. And it also gives you more conceptual fit because it matches the research question you have. It matches, it helps you to actually better respond to the question you have. So I would say when you're using this method, you don't need to be constrained just by one lens, and you can integrate different theoretical lenses and different theoretical perspectives. How it is different? So this is just going one level deeper. Maybe I will stop here and ask any questions. And Katrine, do you have any guidance for me to go ahead or stop for
If you want to,
questions?
you can go ahead, and I guess we have the Q&A session right afterwards when the recording is finished.
Okay, definitely. I'll go ahead. Okay. Just I don't want to have, just too much information overload. So I'm happy to stop. I'll go ahead, but if you had a question, please at least write it in the chat and we can check and respond to them. So how it is different. So one of the things that QCA brings to the table, it's the principle of equifinality, right? So if you use process theorizing, maybe you can have 1-2 paths, or you use variance, it's just like you do your path analysis and you say this is how X influences Y, Y influences Z, and that's what happens. Whereas equifinality means that different combinations you build, right, different combination of causal conditions can produce the same results. So you can have highly successful firms, and you can have two different configurations that explain highly performing firms. And that's the real world. There's just no single one way to achieve success. There's multiple pathways, so multiple combination of these causal conditions that can produce the same outcomes. That's the first principle of configurational thinking, theorizing. Conjectural causation. This is already, I've been using it in my language. An outcome is not produced by single cause acting independently. It is interaction, combination of conditions that produce an outcome. This is very key. And in terms of our findings, we actually go about and find the combinations as, you know, our research findings. This is interesting. Asymmetry, success, you know, lack of success doesn't mean failure, right? The causal conditions that lead to the presence of an outcome are not simply the inverse of those that lead to its absence. So when we, in a lot of the, you know, let's say statistical analysis we do, we always assume asymmetry. X leads to Y, then not X leads to not Y, right? And that's why when we have like a X influences Y, we never we can't reverse it in a way, right? So we often assume symmetry, but in this case there's causal asymmetry. So lack of one condition just doesn't mean, you know, the outcome will be opposite, because one condition is not acting independently. There's combinations. So when we have one lack of a condition, the interaction is different. We can't just say, okay, now it's going to be failure. There might be still success. It's just that different path or different combination of attributes that produce the success outcome still. This is really, really powerful, because this helps us actually go out to organizations and say, this is one path, and if you don't have this, it's okay, because you can compensate with these other combinations or things. Whereas we can't do that in variance research. And each configuration is meaningful, right? In variance research, when we collect our survey data, we go and maybe we will delete some of the data that we thought, oh, doesn't have variation, or oh, doesn't have this and that, we will delete them. Here, we're building on really deep qualitative knowledge. So each of those cases, even if it doesn't repeat, like it just happened in that one country that they had oppressive government, that's a distinct configuration. That's a distinct combination of causal conditions that produce the outcome. So each case is important, exactly like qualitative research. This is sort of really important just because how do we change? Because a lot of our training is based on, you know, variables. But in QCA, we actually have sets. It's based on set theory. That was the mathematics of it that I really got interested, right? So from measurement perspective, we go typically with variance research. We have Likert scales, you know, how satisfied are you, how quality is this thing. Whereas in here, we have sets. We have a set of high-performing firms. And a case can be a member of that fully or partially. That's where fuzzy sets come in, right? So we don't say this goes high, the performance will go high. We say we have a set, a collection of firms that you know, are performing well, and each single firm will be a member of that. So we assign membership scores to those high performing sets, something I will come back to do. So we have dependent variables, you know, we try to explain the variation in our dependent variable in variance theorizing. Here we have presence or absence of an outcome that we have qualitatively, hopefully, observed. Constructed populations, I typically build my own data sets, you know, but here your populations are given and you sample from them. Your correlational, this is set theoretic. So as you know, correlation is not causation, and set theoretic relations, they're not fully causation either, but they take you far more than correlations to explain and build theories. In data structure, you have a correlation matrix with variance. Here you have a truth table, which shows you what are the configurations or combination of attributes. I'll show you truth tables from my own research as we go forward. And causal logic, net effect, here we build causal recipes. Causal recipes are basically, they call it recipe just because it's a language Reagan brought in, I think, that combination of attribute, causal condition 1, 2, 3 will give you this outcome. It's a recipe. You can put the ingredients in and you can get the outcome. And it's much closer to causation. Of course, when writing papers, I've received a lot of advice that don't use the word causal condition, don't use the word causal for that matter. But this is sort of the heart of the methods, despite the review process and the way we look at causality. And of course, we have counterfactuals. In variance research, we really lose that deep case. We actually don't collect it. We don't know it. But here, because we know a lot about our cases, we engage in that analysis process. And for that matter, it's an abductive research method, right? Abductive reasoning approach, where we can go back between the theory and our data and really push our findings into something that adds to existing literature. So variables versus sets, I'm not going to spend a lot of time on this, but this is basically how I explained to you. We don't have variables here, we have causal conditions and let's say decentralization. You can have a variable to measure degree of decentralization. In various approach, you can have high or low, right? But here we have membership scores in the set of decentralized organizational structures. And firm A can be mostly in that sense. If the score is 0.85, it's fuzzy. It will be mostly out if it's 0.3, and it will be crossover, not fully in, not fully out with 0.5. Typically, Charles Reagan suggests to do 0 for fully out of that set, meaning you're centralized, you're not decentralized at all. 0.33 for, to some extent, decentralized, 0.67, and 1 for fully, for example, decentralized. So we belong with two sets, the firms, the cases. Even the causal conditions we have, they are viewed as sets. So how do we build the configurations? This is the part that becomes mathematical. Yankee Park, I really like the two logics they mentioned. We first need our factorial logic, and then we need our combinatorial logic. Factorial logics basically means what are your causal conditions, or what are the causal elements? Element is the other language that I think Yankee Park uses in the MSQ paper, right? And there could be core, meaning that the score is high, it's really important, or peripheral elements. And then in the combinatorial logic is, okay, I have these causal conditions, the ones that Reagan had, like austerity and oppression and so on, but how are they related together? What are the combinations that produce the outcome, right? So that's what this combinatorial logic is, where we bring the tool, we bring the software in to help us with Boolean minimization, to actually go from a lot of the cases we have collected data on to parsimonious set of combinations of causal conditions as our mid-range theory. To be able to produce that mid-range theory, that Boolean minimization, you use truth table algorithm. How it works, it's sort of, you define what is your causal conditions, exactly like the Excel file I showed you from Charles Reagan. These are my cases, these are the conditions, these are the scores for each case, and this is the outcome that was achieved. And for each, you have the values. In the software, it actually builds all of the possible combinations. So if you have k conditions, you will have 2 to the power of k combinations, but you haven't observed all of them in practice. Only some of the combinations you have observed them. So it's sort of, that's why it starts to minimize the solution space because of that. And then there are repeated patterns you have seen, so it gets further minimized. And then sets are subset of other sets, so it gets further minimized, etc., until you get consistency scores above 85%. I will explain what those scores are. So, and you minimize until you get to really parsimonious combination of attributes that you can explain the outcome with. Typically in research papers, we also report intermediate solutions, and the parsimonious solutions sometimes just gets you to one condition. So intermediate solution actually has your counterfactuals in as well, and so it's a much more robust solution typically. As I said, key is this idea of counterfactual or abductive reasoning, to go back and forth in your analysis to resolve all the contradictions you see based on your deep knowledge of the cases and develop your theory. Final slide on the matter before I present my own work on this, my own research on this. In variance research, we go after some rigor criteria. For example, we go on R square, or you have your confusion metrics. You try to reduce your false positives and false negatives, or whatever you do. We look at R curve. We look at all sorts of metrics to make sure that we have rigor in our analysis. Rigor here translates into two scores we create, two metrics. That's the consistency metric and the coverage metric. Consistency metric really tells you that if how well or the degree to which a configurational causal condition is a subset of outcome. That helps you how consistently with those combinations the outcome will be generated or seen. With coverage, it's an empirical evidence of how much the data cases you have, you're able to explain with the combinations, with the configurations you have developed. I won't explain them further because I will come back to them of what these exactly are and how they manifest in research. So I'll look if there's any questions. Okay. Perfect. So I have a question of where do fuzzy sets emerge from. I will answer that very quickly. That's the most interesting part of the problem. How do you actually get those membership scores? Very painful, very hard, but it's really good. I have another question. I'm just wondering how the limitation of survey-based QCA studies can be addressed. So yes, you can do follow-up interviews. Let's discuss that at the end, just because I want to really everything to sync before I discuss the survey-based approach. Okay, so this is a paper I published with QCA in JACE, in Journal of Association for Information Systems Research. So as I told you, I study analytics teams, data artifacts, and so on. For some reason, my deck is not moving forward. Okay, maybe I just need to come back to it. Okay. What was my problem statement? I'm also going to quickly look at time. Okay, I'm doing really okay. So what was my problem statement? When I started my PhD in 2011, I was really interested to understand how companies create value from analytics. And that at the time, it was really, really early on. Tom Davenport's paper of data science is the sexiest job of the 21st century was just published. So I was really excited about my topic. And one of the ways I looked at it, I've looked at it from many different perspectives. One of the ways when I went and did my contextual expert interviews in the first year, I really realized that, analytics groups go and sit in a center of excellence and they don't have business knowledge, they don't have the business understanding of things, and that's why they get it wrong. And this relationship between them, it gets into a lot of tension, and more business people are asking for analytics solutions, and there's so much requests, and this relationship just breaks up because analytics groups can't learn everything about business. And imagine a large organization and you need an army basically of analytics people. So I really started to look at, and there were a lot of questions executives were asking: where should we put our analytics teams? Shall we be embedding them within our business groups? Shall we create centers of excellence, centralize them? What shall we do? So I really came at this question, not as part of my PhD. It was kind of part of my PhD, but this paper was developed in my sort of postdoc time. So my PhD actually was quantitative. So I did a survey on the value sort of aspect of this, and I measured how you can get synergy between the groups and how that synergy explains the value. What does it mean to have synergy? But then that was all survey based with some contextual interviews. Then later in my postdoc, this is where I really got interested in this sort of understanding things deeply. So I did qualitative research, and then because I really was interested in maths and engineering aspect of things, so I really formalized it mathematically. So I will see how I went about this work. So research question. So how can relationship between analytics business groups can be configured to facilitate knowledge integration in data-driven organization initiatives? I use the word relationship because I didn't want to have any assumption of structure. I didn't want to say, even the word group was very purposeful because I didn't want to say we're going to have a COE or it's going to be a team working under. I wanted for the configurations to emerge and to tell me if we should have a formal structure or informal structure. So that's why I didn't have any kind of word. But at the end, I wanted to understand those sort of team group structures and so on. So that was my research question. What is really, really important here is to understand what is a case. In your research, so in Reagan's research, a case was a country. A case could be an organization. In my research, a case, and later on, this is where SE actually helped me to do this, because I was saying a relation, my case is a dyadic relationship, right? And my SE actually told me to really frame it, come from that, because that's how I was collecting data. I had gone out to two really large organizations and I have looked at any initiative, analytics initiative they had, that important initiative that was happening concurrently in those organizations. So that was my case. And in each of those initiatives, I looked at what is the relationship, what is the dynamic relationship between analytics and the business groups. So basically, this is my picture of it. Analytics groups in blue, they come from a different domain, different community of practice. Business groups red. And what I'm really interested for, based on my PhD, I knew that we need the purple. We just having blue community, just having red community, not enough. We needed the purple. We needed the combination hybrid of the two to be able to create value. But how? What are the practices? What are the processes? What combinations can you actually, successful combinations can you actually create in these initiatives to achieve the same outcome of, let's say, success? I will tell you what my outcomes were. Because this is sort of following, Park's logic. So first I need to know what are my factors, what are my causal conditions in that relationships, right? This is a blue ocean. What are actually my causal conditions? I want to understand their combinations, and what is the outcome. So that's stage one for me. So I call them within case analysis. I'll show you my data set as well. So from those two organizations, I think I identified 37 different initiatives, right? So 13 different initiatives, so 13 cases or instances of this relationship. So that was the within case. I analyzed it qualitatively. I embraced those two organizations just as qualitative researchers would do by my heart, each initiative, what happened in them, what outcomes they achieved, and so on. I collected heaps of data, observations, secondhand data, online data. I did heaps of interviews, and I used qualitative approaches and engaged in concept development. So I developed my concept. So if you're writing a qualitative research paper, you probably will use this method, and then you will try to abstract out the relationships, and then you have, your process models or something like that. But I developed these concepts that were my causal conditions and outcomes, but the relationship between them, from my perspective, it was causal complexity. From my perspective, there was a combination. The combinations would have produced the outcome rather than just one factor producing the success outcome for those initiatives. And by the way, I also, in my initiative, I also had failure initiatives. And it's very important because failure initiatives actually help you in the reasoning in Boolean algebra to know what combinations you should not make. So it's actually used in the reasoning process when you have failure cases. It's encouraged you identify failure cases, which is again another advantage of this method, this approach of theorizing. So in the cross case analysis, I used QCA and I developed what are the combination of attributes that develop the outcomes I identify. So I went into my research with qualitative. I had some lenses from research and from my PhD. But I went with an open mind to really identify what are the dynamics in these relationships that help them achieve outcomes, and what are those outcomes from an organizational perspective. So let me just jump here. These are my cases. So when I was telling you, initiatives, so each initiative, for example, central dashboarding relating to Blue, that's one example of Blue. This is one business group, an example of all dashboard users, and this was what was the relationship, what was the initiative doing. I had files after files explaining each of these different groups. For example, they had a dashboarding group, but they also had a central data group, and then they had central data group have relationships with product people versus cybersecurity. So I identified so many relationships, all the levels in the organization, executives versus, they had some external relationships, external groups, where HR analytics was being conducted. Then they had initiatives in there with dashboarding groups and HR people. So this is not all of it, but as I said, I identified in around 37 cases of the relationship. Then in within case, I developed the concepts, as I said, right? So 3 of these became my causal conditions, and these 2 were my outcomes. In terms of my causal conditions, what I learned from my qualitative data, that sometimes the structure is important, sometimes it's not. But what was really important was the cardinality of the relationship. Is it a scoped connection, one-to-one, one group with another group, or is it a scale relationship, one group talking to many groups, which is what many centralized groups do. And it was very present in my study. That's where you are, decentralizing things, and one group tries to, provide many groups. And sometimes you had many to many. So this is here where everybody, like Yammer communities, where all the analytics people, business people were brought together to actually talk to each other. So in a way, if you think about this, when you do network research, network analysis, you make it quantitatively, right? What kind of connections, and you build the network structure. It's as if I did qualitative network analysis, right? So this is what the connections are. What are the ties? Are they scoped, one-to-one, one-to-few? Or are they scaled, meaning one-to-many and many-to-many? And then what kind of exchange? I know that there's a knowledge gap. So what kind of exchange of analytics knowledge and domain knowledge was happening between them? I developed 3 types based on my data. And what kind of incentivization was used? Was it based on power, that relationship? This is where some of the structures, formal structures could come in. Or was it based on just value? There's something, value in something, let's jump and make a self-organizing team and just solve this and help a school. Some of the public good projects, that's how they were emerging. Or is it just because next door they're doing it in the other function, we also should do it because we want to be looking good in front of our CEO? So I developed these, and based on my qualitative, that these emerged from my qualitative data. But it's a key question: what are the causal conditions you're going to be using? And in terms of the outcomes, these are this is what I developed. What I saw, that some projects really, because analytics actually, you develop bottom up new ways of working, new behaviors, new mindset, new tools in the organization. It's not traditional IT that you develop it, you buy it and then you launch it to everyone. It's really bottom up. And then I noticed that some of these were then shared So you not only wanted to, because you wanted efficiency and optimization, so there were some relationships that were really focused on innovation, developing new things, new emergent things, and so on. But some of the relationships, they actually weren't interested in innovation. They just wanted to share and diffuse and make sure everyone at scale had access to the innovations. The companies where I was studying, one of them was 100K plus in employees, close to even to 150K employees. So scaling was really important. And this is the configuration model I developed. So these three causal conditions together combine to produce the outcome. And sometimes I had two outcomes. Sometimes they produced emergent data-driven ways of working. And sometimes it's just about convergence because they really want to share and create economies of scale. And this is where, and Katrine asked, how do you actually get to that membership scores? It's really hard, actually. Not, it's possible. There's an approach. If you look at my paper, other papers, there's an approach to do it. It's a really painful work. So this is we build a calibration framework because you don't have numbers, you have qualitative data, and you are gonna turn that qualitative data into fuzzy membership scores. So you need a calibration framework, so you do it systematically and you really understand, is this a one-to-one? Is this scoped, this case, this first initiative? What about second? What about third? And you need to be able to differentiate them if they're fuzzy between 0.33 and 0.67. So here is part of my calibration framework for each of the causal conditions. I defined them. I identified the indicators for each. When there's going to be a connection, it's going to be fully in, meaning that a scope connection exists. I didn't view it as fuzzy for this specific causal condition. And when it was zero, connection doesn't exist. And also for scale connections, this is one to many and many to many. And then I looked at knowledge transfer, and I looked at the different ways and the different indicators I had for them. And when it is that I'm going to give one, when it is that for one case, I'm going to give it 0.67, when it is that I'm going to give it 0.33. And for each case, I looked at the indicators, what was present, was it purposeful primary practice, was it purposeful reinforcing secondary practice? So I developed this language, this threshold for me, so I can go into my qualitative data and turn that qualitative data into fuzzy membership scores. After you do that, you have this. Sorry, this is not mine. This is Reagan's. This is mine, right? And this is reduced, by the way. I can quickly show you actually because I did open my Excel file here. No, that's Reagan's file. This is my input file. So do you see one-to-one, one-to-few? So these are, each row is a case, and these are the values, the fuzzy membership scores that I developed for each of the cases that are presented in a row, right? And then what you do is that, of course, this is for each case, some of these will be repeated. So that's where the reducing or Boolean minimization comes in. So let me go back to my deck. When you start minimizing this to some extent, for example, let's look to this column number, right? You see the number. So this first combination of causal conditions that you see, I saw it only once. The second one, I saw it 4 times. The third one, interestingly, I don't know, maybe that's a COE kind of approach, I saw it 13 times. This last one, I saw it 9 times, right? So in terms of emergence, this is the truth table at the top here. And what you see is that it's reduced a bit. So it has the algorithm, actually, the software has identified which are the similar rows. So, and there's no contradiction, same outcome has achieved. And then it just says, okay, I have 13 different combinations. And I love it because I can see when there's a scope connection, and when there is collaborative action, and when there's value proposition, you get the outcome of one for emergence. Emergence happens based on my cases, right? And there's 13 different cases. So consistency for it is very high, right? So this is the truth table. Now from the truth table, you start to do your truth table algorithm. This is the algorithm that minimizes this into set-theoretic relations. They're basically relations. If you have done databases, you would know the relations from there, or you've done set theory, you know relations from there. So similar to, I followed, Youngi Park's approach, and I built my sort of finding table figure like this. So configurations that explain emergence and configurations that explain convergence. And when you have a big black circle, it means that it's a core important causal condition. When you have a smaller, it means that it's periphery. For me, collaborative action and all of the core conditions were actually part of the knowledge transfer. When you have the crossed circle, it really means that this in this particular configuration, scale should not be there, right? It should not be there. When you have nothing, it means we don't care. You can have that condition there or not, doesn't matter. And this is sort of relational representation of the emergence. So you really literally, this is your theory. This is the knowledge you produce. Emergence happens. This is the intermediate solution. As I said, the counterfactual happens in it. Counterfactual happens in it means that I, as the researcher, go back to data and come back and say, this contradiction exists and this scope should be there. And I literally in the software, it's a pop-up window that tells you to say your say as the researcher. This is not possible in variance, but this is qualitative research. You know it as a researcher. You have developed that understanding. It's just you are mathematically formalizing this. And I identified 5 configurations. So here you say scoped and not scaled, negation, and not educate, negation, plus collaborative action, will produce the emergent. And parsimonious solution is the much reduced, much minimized relation. The other thing I should mention at this stage is that from theory, we develop knowledge. If you look at the philosophy, it says you have knowledge when you meet the sufficiency necessary criteria. With intermediate solution gives you the sufficient. This combination is sufficient to achieve the outcome. The other thing you can see is the equifinality, right? There are multiple, here when you see the plus, that actually means this way, this combination, or this other combination will give you emergence, right? So for emergence, there's 2 configurations. Both will produce the same outcome. For convergence, you have 3 combinations. All 3 will produce the same outcome. That's your equifinality. And you can easily also see the asymmetry thing, because when this doesn't exist, that doesn't mean that it's going to fail, right? And so on. So let me go. This is where I'm finalizing, and we'll open for questions. From my perspective, after doing this methodology and this theorizing approach multiple times, and really engaging with the literature and community of it, one of the key ways for success was really that qualitative deep domain of the cases and the abductive process to go and the back and forth to adjust what are the really causal conditions that are important. It's not as I present to you like that these were the 3 things. I went trillion times back and forth between my qualitative, even when you do qualitative data, you code and recode and recode and recode. So I went through all that process to just understand what are those causal conditions. But then I didn't know the relationship between those causal conditions to have a theory. The fact that I only have concepts now doesn't mean I have a new model, new theoretical model. So I had to specify what are the relationships between these different concepts to be able to have a theoretical explanation. So this abductive process and the deep knowledge of the cases really, really helped me. And I have to also say that to be able to do this qualitatively for that matter, you actually need good access, which I was lucky with, and I had it through MIT Research Center. I had really deep access to the cases, so I could develop that understanding. And the key achievement I think you bring from this methodology is that this method gives you the ability to bridge research and practice. Because the configurations you develop, which is these are the configurations I developed, I actually went out to practitioners. I wrote practitioner pieces and said, based on my configurations that I have developed, there are 5 different ways to structure your analytics teams. And these are the blue and the red from my research and the configurations I built. So this is a really big, strong. So if you are sitting in a research center that does impact is important, this method can be for you. Okay, I'm going to close here. I acknowledge I didn't talk about the survey approach, but I guess that will come in the questions. So let's open it for questions.